All right, so today what we're going to do is we're going to continue to look at transformations, but we're just going to continue what we took a look at last day. So here's our first example. So for the given transformation, for the given transform function, I'm going to ask you to describe the transformations involved and show the stages in a sketch on your graph. So we have the function y is equal to x cubed. Okay, so now we're going to eventually turn that into the following equation. Y is equal to negative x plus 1 cubed plus 2. So here's our solution. Leave a little space so that we can put our graph underneath here. So first of all, here's our solution. So we start with y is equal to x cubed. So you could graph that and eventually you'll see something there. So now, here's what we'll do. And you have y is equal to x cubed. So what we're going to do is we're going to quickly plot the points for y is equal to x cubed. So you have y is equal to x cubed. Punch in all the points, those are the values that you get. Now, for y is equal to x cubed, let's see what actually happens. So when we have y is equal to x cubed, we're going to eventually turn it into this thing here. And what we're going to do is we're going to go from right all the way to left and apply all the different transformations. So now the leftmost transformation gives y is equal to negative x cubed. Now, y is equal to negative x cubed takes everything that's in red and flips it. And that is going to be in a different color. Let's make it black. So this point here now goes all the way down to here. This point goes to here. So instead of positive 8, we're going to have negative 8. Instead of positive 1, we're at negative 1. At 0, we're still at 0. We're here and here for our last spot. Now we can draw our curve. Now, as you draw your curves, I would say take the moment and actually write your equation beside it. So this is y is equal to x squared, and then this one is y is equal to negative x cubed. Sorry, this is x cubed. Okay, so now that we've got x cubed, let's see what happens next. Our next transformation is y is equal to, keep the negative sign, but now we're going to go and change what we have in our graph to be x plus 1. So now we're left with x plus 1 inside our bracket, cubed. I'm going to make that a green picture. Now, for the first one, you're going to say that this was vertically flipped. And then for the second one, it wasn't just vertically flipped, it was shifted. So it was, you could say either shift left or horizontal shift. And we're going to go, how much is that? Left 1. So we take that and move it to the left 1. So now what we're going to do, take each of the stuff that's in black and move it over one spot. So each of the individual points just get moved over exactly 1. So now we graph a nice curve that kind of matches it, right? So now that's the equation y is equal to negative x plus 1 cubed. So now that I've got that basic graph, now we have to go and take a look at what the plus 2 does on our graph. Now, in order to show that, what you're going to do is you're just going to take what you had here and add the plus 2. So now we're going to have y is equal to negative x plus 1 cubed, and then we're going to go plus 2. Our graph is going to be blue for our final graph. And this is a horizontal, no, not horizontal this time. This one is a vertical shift of 2. Vertical shift up 2. So we take each of the points and we move them up 2 points. So on our graph, I took the time to make sure I could see my original graph and just add those points. So here's my first point. Here's my second point on my graph. Here is my third point at 2. And then fourth point. And then up to from here. And then we just draw our graph. And it goes on forever. And then we say that blue graph is y is equal to negative x plus 1 square cubed plus 2. And there is how we go and show all the translations in the graph. Okay? So imagine we had the following equation. Y is equal to the root of x. And then what we're going to do is we're going to transform that into the equation y is equal to 2 minus 2 root x plus 3. Now, as an aside, I will tell you right away that we have to change this into a better form. I have to change this equation into a better form. And that better form is this. Y is equal to negative 2 root of x plus 3 and then plus 2. It's just rearranging the base function so that it's at the front of our equation, very similar to what we have here. Okay, so now let us go and graph this thing and describe its transformations. So now what we're going to do is we're going to take our base function, which is y is equal to the root of x, and we're going to graph that using the red points that you see here. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So we'll graph those points. We'll write y is equal to the root of x. And we're done for our first graph. Now, what we need to do is we need to graph the next thing. So when we look at our equation, you notice that there is a minus sign in front, right? That minus sign tells us something. So let's go and do that. So we get y is equal to the negative of root of x. Now, I'm going to draw that in black. And now what happens is all these points are flipped vertically. So all the points are flipped vertically. Now that I'm flipping them vertically, that means 0 still stays, right? But 1 goes here. Then the 2 that was up top here goes to negative 2. And the 3 that was here goes down to negative 3. So now that I've got all those 3 points, I can just graph my bottom half. So now this is y is equal to negative root of x. So now let's go and take a look at what happens to the 2. So the next transformation is negative 2 root of x. And that comes from the fact that there's a 2 after the minus sign. So that 2 is going to do something crazy to our function. So I'm going to use green in order to describe that. So this one here is going to be stretched vertically. And we're going to say vertically by a factor of 2. By a factor of 2. So now that I've got that, each of the y's get multiplied. So 0 stays at 0, but now we've got 1 goes to negative 2, 2 goes to negative 4, That's 3. Oops. 1, 2, 3, 4. Yep, that's right, -4. And then 3, 1, 2, 3 goes to 6. 1, 2, 3 more. 1, 2, 3 more, which is here. So now our new graph looks like this. So now you can write beside it y is equal to -2 root of x. Now, the next transformation that we're going to identify is what's happening under the root sign. So we're going to go and rewrite this equation that we have here as y is equal to -2 root of x plus 3. Now that I've got that, this I'm going to change to a purple color. And this is going to be a shift left by 3. So what does that mean? It means all of the points in green move exactly 3 points to the right. So there's my first point. 0 goes to -3. Then I count 3 over from this next point here. 1, 2, 3. And 3 over from this point. 1, 2, 3. And 3 over from this point. 1, 2, 3. And now we can graph. And you can state what your graph is. Y is equal to -2 root of x plus 3. And then that's it. So now our final transformation on our graph is this +2. So that +2 has to mean it does something. That +2 always tells us that it's moving up or down. If it was plus, it moves up. And if it's down, if it's negative, it moves down. So we have y as our final calculation is y is equal to -2 root of x plus 3. And then we add 2 to it. So now I'm going to use a different color pen. And we'll try a new color. Let's go for a nice purple. All right, so now that we've got our nice purple, here's what we've got. So this thing is a shift up by 2 points. So this first point at 0, -3 goes up to here. The next point goes up to here. The next point goes up to here. And the next point goes to here. So now our graph looks like this. And we can say that this is our final graph, -2 root x plus 3 plus 2. And we are done. That's how you graph it. And this is your homework for the day. It's going to be page 65. Number 16, 18, 29, 30, 31, 32, 33, 35, E and F, and 39. Take your time with this. This is what we need to understand.